All right, so yesterday's homework we covered step functions. Step functions is a part of the piecewise function family. So today we're going to finish up with our piecewise functions. Step functions are a type of piecewise function. These kinds of functions we see in pieces, okay, on the graph. You just see pieces of functions all over. So on number 1, when it's asking, first we go to f of 5, and you will notice that we are going from, you can see there's 3 different functions here, and that's why it's called that's why it's a piecewise function. And so the first one where it's 5, I go up to the y-axis because this is almost the same thing as y equals 5. When you have that, it's going to be a horizontal line. So I go to the 5, and now I have to look at the boundaries. The boundaries of my width, or my domain, should be from 0, the x is from 0, which is right here, all the way up to 4. 1, 2, 3, 4, right here. And what I'm going to do is really kind of follow that up. Okay, so the first one, I'm going to do a solid circle because it has an underline, it's included. And the second one's going to be an open circle because it just says less than. There's no bar underneath it. Is that clear? Okay, the second line I'm going to do is at 1. So I go up to 1, and now my boundaries, I'm going to go everywhere from 4 to 8. 1, 2, 3, 4. Now it's going to be include 4, so we do our solid point. And we're going to go all the way to 8, but not include 8. We're going to do an open circle. And we draw that line. The third one is for y equals -3, or f of x equals -3. I go down to -3 on the y-axis, and then I'm going to go over every 8 units to the right. It should include it all the way over to 12 units. Is that making sense? So if I asked you, state the domain of the entire piecewise function, how could we talk about it? Sophie?
Well, 0, do you want me to say?
Yeah.
Okay. 0 is less than or equal to x, which is less than or equal to 12.
Right. So we are going all this area, all in here, that width is my domain, because every single point on those lines, like this is 1, this is a point, that would be, that x would be 1. This x would be 2. This x would be 3. This x would be 4, but it's not up here, it's here. Do you see how every single x is being used all the way, including the fractions, all the way to 12? Are you guys with me? So that's why my domain will look like this. And my range, and it's constant. It's a constant. But my range, the only y's, if I pick those points that you're ever going to see, will be this -3, okay, 1 and 5. Is that clear? Yes or no? Thumbs up yes, thumbs down no. Okay. Then the next part, we are evaluating. So when I'm doing like the f of -4, answer the following questions. So basically what they're saying is, when x is 4, what is y? So I start at my origin. When x is, the first one says -4, 1, 2, 3, 4. What is the only line I can look at? Is it up or is it down? It's up. You can only go to here. What is my y? 2. That's why it's 2. You guys with me? When x is 2, The f of 2. 1, 2. What's my y going to be? What line does it find? What? Negative 1, 2, 3. We're all the way down here. Okay? When x is negative 2, okay? 1, 2 in the negative direction. I've got this one that's solid, and I have this one right here that's open. So when x is negative 2, what's it going to go with? 2, the solid one. It's not on that negative 3 line. Are you guys understanding this? How to evaluate? And then when our x is 5, I move all the way over to 5, and what does it go with? The 4, right here. Are there any questions there? Then it asks you to write the function for it. So we're basically writing the function for each line. Let's go from least, okay, I'll go from left to right. So this is really what? Let's go this line right here. How do we write that? We're doing our f of x. How would I show that? Let's do that first one that I just highlighted in black. The f of x, this is solid, and this is open. Okay, how do I write that, guys? What is that equation? Sarah.
It's negative 5.
Whoa.
2.
Hold on. It's what?
It's 2.
It's 2. Now, what are my restrictions?
Negative 5.
Negative 5, because it's going from the smallest, which is here.
Is less than x.
Which is
Less than or equal to negative 2.
negative 2, because I'm going from there to there. Are you clear on how to write that? Are there any questions? Is there any confusion? Okay. How do I write the next one? Right here. Let's do that next one there. Matthew.
Negative 3.
Negative 3. And what am I doing?
It's negative 2
It goes from negative 2.
is less than x,
Less than, not less than or equal to. Good.
which is less than or equal to 3.
Or equal to 3. And then my last line right here. Hazel,
4.
it's 4. And what are the restrictions?
3 is less than x, which is less than or equal to.
Perfect. Are you guys clear on that? Yes.
What about 1c?
Hold on one second. This is 1C. Okay. This was this part right here.
No, 1c. Number 1.
Okay, 1C. Oh, that's 2C, you're right. Don't worry about that. They're assuming you've had quadratics, and we'll learn about the zeros and the x's, so don't worry about that. They're talking about the x-intercepts. Are there any x-intercepts here on that graph? No, but you wouldn't have known that term, zeros, until you get through quadratics. We did skip 2B. Chi-Wan states that the range is negative 3 is less than or equal to y, which is less than or equal to 4. Is he correct?
No.
Our range is only negative 3, 2, and 4. It is not constant. He is assuming, he's probably talking about, he's thinking that you go from the bottom to the top, everything. Is everybody clear on that? All right. So the next one, we're basically we're following these directions. The first equation is at 70. So I go to 70 and it says my boundary is from 0 to 3. Here's the 3. Here's 0. Follow them up. The 0 is going to be solid and the 3 stays open. Okay? The next one, I go to the 50 and I'm starting at 3 and it says it's solid because it's equal to, and it goes to 6. The third one, I go to 35. Starts here. And it goes all the way. And it includes, they're both solid. Are there any questions? All right. Number 4. Number 4 was a bit of a problem because, well, it wasn't really a problem, but the problem is that nobody's showing any work for it. They're answering questions without work. So what I made the kids that stay here do, I made them graph it. You either have to show math or a graph to prove your way. I couldn't figure out the math, so I started graphing the situation. So the first thing I'm going to do is make a table. Make it's going to be tough because making a table. A coordinate plane. Now, one of the things we have to, what am I comparing when I make my table? My graph. What are we comparing? Sydney.
The amount of time you stay and the cost.
The amount of time you stay and the cost. Good. Okay, what goes on the X and what goes on the Y? Sarah.
So the amount of time you stay goes on the X.
Right, time is for the X.
Because it's the independent variable.
And that is in hours. And this is the cost. And that's because it is independent. Cost depends on time. So once I know that. Now, the cost, it goes in increments of what? The cost goes in increments of what? Jordan.
1 hour or 1.
Cost.
For the cost? Oh, 3.
Units of 3, right? $3, $6, $9, all the way up to, what's my max? $30. So I've got to make sure my y-axis goes to 30. Let's hope I can get there. 3, let's do 3, 6, 9, 12, 15, 18, 21, 24, and then I have 30, right? Oh, 27. I did that before. 27, and then we have 30. Okay, time is a maximum of what? 24 hours. So I'm going to go 1, then skip 1, then 2. 4, 6, 8, 10. It would be a good idea if you're doing this with me if you didn't do something like this. 14, 16, 18, 20, 22, 24. Now you'll notice I skip lines so I have enough room to write. Okay? All right, so tell me how I would graph my first hour. Tell me about my first hour. How are we going to do it? Connor.
So your first hour is $3.
$3.
So your first point would be 1 to 3.
1 across and 3 up. Is that correct? I'm going to do this. What do you guys think? Katie.
Should it be opposed that?
A what?
Opposed?
Well, what happens if I'm only there 15 minutes is my question. 15 minutes. Hazel.
If you're there at all, it would be $3. So an open dot.
Where?
0, 3.
0 across 3 is going to be an open dot, and it goes all the way over to here, which is a solid dot. For all the way up to, from 1 second to the first hour, 60 minutes you are paying $3.
What I did was I did the
Wait, hold on. Let's finish this and then I want to hear what you did. Okay, what would go next? What would go next? What about for the second hour? How much am I paying, guys? Carson,
So you have an open dot,
where?
6, 6, 1.
No, 1 6.
6.
At the first hour, it's going to be an open dot and it goes to where?
Then it goes to 2,
And
6, and it's in closed dot.
okay, because all the way up to 2 hours. Next, at 2 hours, it's going to be 2 hours, 1 minute. How much is it going to be? $9. So I'm starting my circle where? Where? What is my X? 2 with an open or a closed circle. Open. And what is my Y? 9. It's open and it goes. Are you seeing the pattern here? Yes or no? Okay, so I'm going to keep going. And then at 3 hours, I'm going to 12. It's going to be an open circle and it goes all the way over. And then at 4 hours, it's going to be an open circle and it's going to go, and I do solid here. Okay, then at 5 hours, I'm going to be an open circle and it's going here and it goes to here. And how much am I paying at that time right there? What are we paying? $18. Okay, I'm keep going, right? When do I stop? What? $30 or at? Good, okay. So we have 2 options. Okay, and I'm going to keep going. Now I'm at hour number 7. 7 hours and 1 minute goes to $24. And then hour number 8, okay, goes to $27. 8 hours, 1 minute, or the 9th hour. And then we've got the next, just went off. Now we've got the next one, which is what? I'm putting the open circle at 9 hours. And it goes to where? Is this correct? Okay, so the next one, why? Why is it not correct? It's true, at 10 hours we pay $30, yes.
Because $30 is like the maximum that you can pay.
And
And you can go until 24 hours.
I can go all the way to 24. So I'm going to go all the way over here, and I'm going here. And I think this is the right line, please. So it's solid, and I draw my line over. Okay? Are you guys good? Now, the first question of the homework says, does everybody understand how to do this step function? Looks like steps. So the first question says, explain why the total amount you pay for a parking at Stewart is a step function based on the number of hours you parked. Why is it a step function? Rand, what do you think?
because when 1 hour ends, the new one begins, and you have to pay the $3 more.
From 1 minute
1 minute to 1 hour.
to the end of the hour. These are constant functions. From 1 minute to 60 minutes, every hour you're paying the same amount. Is that clear? Okay. They're constant functions. Then it says, how much would you have to pay parked for 5 hours or 22 minutes? 5 hours or 22 minutes. Okay, what do we do here? Josh.
So they would cost $18.
Right, I go to my 5 hours and I just kind of like see what line it. Oh, whoops, that's not it. That's only at 5 hours. I have to go to 5 hours and 22. Do you see in the middle here? and it goes to this line, and this line goes to here. And that's how we find the $18. If you were doing the math, I guess you would go to the 6th hour. You would go to the 6th hour to substitute it in. Okay, and then the last part says, after how many hours of parking will you hit the maximum charge of $30? After how many hours of parking do you hit the maximum? Is it 10 hours? It's from 9 hours, 1 second, all the way to 24 hours. Do we hit the maximum? So we could say 9 is less than, but not equal to, x, which is less than 24. That's one way to write it. Or equal to. Okay, my time can go anywhere. That would be the domain for $30. Yes?
I got a bit confused because it said 24-hour maximum and it says $30. So what I wrote for C is I wrote 24 hours. I got confused, so I thought it was like 24 hours. Yeah.
So you, anytime from 9 hours, 1 second, all the way, so that's really the 10th hour. Is that clear? All right, so this was our step functions. Now we're going to go into our, I'm going to stop it and start the actual lesson on piecewise functions. Okay? This was from last night's homework on step functions.